Guys and girls, it's Noah time!
So what I want to work with you now is just some basic word problems. Applications of a quadratic function. Quadratic function. And this is going to be part 1. I'm going to do part 2 tomorrow, but for now I want you to get the basic understanding of what part 1 is. It's all really the same concept over and over again, but the key idea is how well can you work with the formulas. Okay. Now, I've showed you the Dubai water fountain, so let's just draw a water fountain. Here's my... This is a fountain. It's not as great as Dubai's, but we're going to assume. And there we go. This is my Dubai water fountain right there. Okay. So great. Now, there's a mathematical formula. I'm going to say this. The height of the water fountain, of the water flow. So if you're in Dubai one day, take a look at that hotel. I think the tallest Burj Khalifa, I think. And Burj Khalifa, yes. And you see that. And then go back to Aberdeen and compare the two. The height of the water flow is given by HT equals to negative 6t squared plus 72t minus 20. H of t is your height in centimeters. HT equals to height in cm. T equals to time in seconds. This is all they give you, time in seconds. Maybe in a second. I may give this a challenge. Your question is this: what is the max height of the water? Okay. What is the max height of the water? Good luck. Here's a word problem. I have a water fountain. It's given by this formula that some engineers come up with. But I want to know how high can this water reach up to. Your task is figure out how do you do this. 1 card to the first person, to anyone who can get this correct. I'm going to pause it here and let you guys fiddle around with this. Everything you know how to do, I've taught you how to do. Now you're going to apply it. I'm going to pause it and let you try it on your own. So I walked around, and here's a typical application question. This is an easy application because I give you the formula. Tomorrow, you have to come up with your own formula. Now, if I give you the formula, really, I just got to analyze the question. They're looking for max height. Now, in order for you to do this, if you look at this question, this is in standard form. Standard form is one of the hardest forms to work with. So let's convert this to vertex form right now. There's only one way you can do but to convert this into vertex form, and that's by completing a square. So let's complete the square. H of t really is saying y. So I'm going to rewrite this using the word y instead, because a lot of you are saying, so I can work with y. See? 6t squared plus 72t minus 20. I'm going to complete the square, and if you completed the square, you should have negative 6 t squared minus 12t minus 20. Okay? That should be minus 6 t squared minus 12t plus 36 minus 36 minus 20. I'm going to bring out this minus 36 by multiplying with this negative 6. And what you should get is minus 6 t squared minus 12t plus 36 minus 36. Oops, sorry, not minus 6. What am I doing? Plus 216 minus 20. Okay. Now I'm going to simplify and use my shortcut technique. Minus 6 t minus 6 squared plus 196. Some of you got up to here, but you didn't know how to answer the question. See, what I'm really looking for is what is the max height? The max height refers to what is the maximum of this chart going to be. So I've been training you how to find the vertex, max, min, and all that stuff. So your vertex, so let's write this down, vertex, min, max. Okay, that's what I've been training you to do from yesterday. This is why you got to piece everything together now. Who haven't asked today yet? Let's ask on a person who haven't picked on. Ramen, what's your vertex going to be, Ramen? Oh, sorry, I didn't hear you. Can you say it again? What's your vertex? It's positive 6 and 196 is correct. Okay. So far, so good. Crystal, what's your minimum going to be? Ooh, sorry, your minimum? Negative infinity. Manraj, I know you weren't here, but take a guess. Do you know what the maximum is going to be? No? Okay. Harneet, what's the maximum going to be? 196. That's my max value. Hey, so this max refers to highest point on the fountain. Okay? On the fountain. That's what it refers to. Highest point on the fountain. So if I were to do a rough sketch, guys, draw a rough sketch for me, please. If I were to do a rough sketch, my water fountain looks like this, 6 and 196. And we'll say it right here. And it opens downward. Okay? Opens downward. The highest point right here is 196, which is correct. So max is going to be 196. It occurs at blank seconds. Here's where some of you are stuck. My x value, x-axis is really time. So they want to know what is the x value when y is at 196. Serena, what's your x value? 6. Because my vertex is x equals to 6, y equals to 196. So when the water is at 196, that's when your time is at 6 seconds. That's what it means. That's what I call application. And this stuff is really useful if you're planning to go to engineering. Because if you're planning to go to engineering and you're going to design a parabolic arch, you're going to have to do a lot of form calculation like this. Where's the highest point going to be? When does it occur? Highest point is right here. It occurs when x equals to 6, or in this case, when my time equals to 6 seconds. For now, I'm going to just probably give you one more quick question, and this is just for you to practice and try on your own. Again, this is called easy application. Easy applications, I'm giving you the formula. Hard application is when you come up with your own formula. It says this: a gymnast is jumping on a trampoline. Do we have any gymnasts in this class? Anyone take gymnastics? On a trampoline. Okay. The height is given by, so the height, how high this gymnast flies, is given by h of t equals to negative 5t squared plus 10t plus 4. H is height in meters. Your question is this: how high can the gymnast jump? How high can the gymnast jump? So someone actually measures the gymnast and creates a formula for his jumping routine. This is the exact same formula. In the Olympics, did you know that they actually hire mathematicians and statisticians to calculate how high people jump? And they can say, this is your angle, you're off by a few degrees, to improve their score. Guys, gals, I'm going to give you a few minutes to try this on your own. You should be able to do this now. This is called an easy word problem. Why? I give you the formula. You just got to apply what I've been teaching you. I'm going to pause it right here. So first thing I notice is that, look, this is in standard form. I can't work with standard form. It's the form that's really nasty. So what you're going to do is convert this into vertex form. And we're just going to complete the square. Negative 5 t squared minus 2t plus 4. Okay. Nothing too bad. I make it very simple. I'm not going to rush it. Minus 2t plus 1 minus 1 plus 4. Now, I'm just going to bring things out. Minus 5 times t squared minus 2t plus 1 plus 5 plus 4 negative 5t minus 1 squared plus 9. Guys, gals, from here, this is all I need to look at, and I can figure out the rest on my own. Okay? I'm going to just ask you, sir, as some random students, Darren, what's the max height going to be, sir?
9.
Max is 9 meters. So this gymnast can jump exactly 9 meters. And Darren, choose a student for me. Choose a female student.
Harney.
Harneet. When does it occur? Time. Where's Harneet? Who's Harneet? I'm still learning names. Oh yeah, Harneet. You didn't get that? So let's look at this one. We know my height is 9. So to find out when it occurs, you got to look at the vertex. What's the vertex of this, Harneet? 1, 9. So the max height is 9. It occurs when x equals to 1. So this gymnast can jump 9 meters at exactly 1 second, the moment he lifts off. Guys, gals, that concludes word problems, easy part 1. I give you the equation, you just do the stuff, analyze it, bada bing, bada boom, life is good.